All right, today we're pulling back the curtain on Git. You know, that thing you probably use a dozen times a day. But how well do you really know what's going on under the hood? We're going to go way beyond the basic commands and turn Git from this mysterious black box into a powerful toolkit that you can use with total confidence.
I mean, think about it, right? You type git add, git commit, git push. It's just pure muscle memory. But what's actually happening when you hit enter? What is the secret sauce that makes Git so incredibly fast and powerful, and let's be honest, sometimes so darn confusing? Well, that's exactly what we're going to unpack today.
So, here's our game plan. We're going to start with a quick trip back in time to see what the world looked like before Git, and I promise it'll make you appreciate it so much more. Then we'll dive right into the guts of it. The database, the 3 states every file goes through, and of course the magic of branching. We'll even tackle the scary stuff, like rewriting history, and then wrap it all up by seeing how this comes together for modern teams.
So our first stop is what I like to call the source motel. This is a peek into the world of version control before Git came along and, well, changed everything.
This quote from Ken Thompson, one of the creators of Unix, is just perfect. It absolutely nails the frustration of the old days. See, early systems were all about locking files. So imagine you need to edit a file, but your coworker has it checked out and is gone for lunch. You are completely, totally blocked. It was a huge bottleneck. The whole evolution really happened in 3 big jumps. First, back in the 70s, it was all local. Think of it as version control for just one person on one computer. Then, the 80s gave us the client-server model with tools like CVS and Subversion. This was a huge step forward for teams, but it had one giant single weakness. And finally, in the 2000s, Git showed up with a distributed model, and it was a complete game changer. And here it is, the key difference. On the left, you've got that centralized model. One big server holds all the code. If that server crashes, or if you're on a flight with no Wi-Fi, you can't commit, you can't see the history, you're basically stuck. But with the distributed model on the right, every single developer has a full, complete copy of the entire project history right on their own machine. This was a massive insight. Suddenly, there was no single point of failure, and you could work from anywhere.
Okay, so now we know why Git was born. Let's pop the hood and see how it actually pulls off all that speed and power. We're going inside the mind of Git.
If there's one thing you take away from this section, let it be this: hashing. Specifically, something called the Secure Hash Algorithm, or SHA. Just think of it like a unique digital fingerprint. Git takes any piece of content, a file, a folder, a commit, and runs it through this process to get a unique 40-character string. This fingerprint is everything. It's how Git knows, instantly, if even a single bit has changed.
And what's really amazing is how sensitive it is. Just look at this. We're taking some text and using a git command to generate its unique hash. See that long string of characters? Now let's say we change just one tiny little thing. The resulting hash is completely different, like not even close. This is the magic behind Git speed. It doesn't have to compare 2 massive files line by line, it just glances at their fingerprints. If they're different, something changed. Simple as that. Okay, so here's what really makes it all click. Git uses those fingerprints to manage just 3 fundamental types of objects. First, you've got a blob. Weird name, I know, but just think of it as the raw content of your file, the data itself, nothing more. Second is a tree, which is basically a directory listing. It doesn't hold any content, it's just a list of file names pointing to the unique fingerprints of the blobs and other trees inside it. And finally, you have the commit object. This is the glue. It points to the main tree for that snapshot, adds the author, your message, and, this is the crucial part, it points to the commit that came right before it, creating that unbreakable chain of history.
So now that we get the building blocks, the blobs, trees, and commits, let's see how they fit into your day-to-day work. Because every file you touch goes on a little journey through 3 very distinct states. Okay, so first, when you edit a file, it's modified. It's just sitting there in your working directory. Git sees that it's different, but you haven't told it to do anything yet. Then you run git add. This moves that file to the staged state. Think of this as putting something in a box, getting it ready for shipping. You're telling Git, okay, this exact version of this file is what I want in my next snapshot. And finally, you run git commit. Git takes everything in that staging area, creates the tree and commit objects, and permanently stores that snapshot right in your local repository. Done.
All right, now for the feature that truly makes Git a powerhouse for teamwork: branching and merging. This is how entire teams can work on dozens of things at once, without constantly tripping over each other.
So here's the most important thing to understand about branches in Git. A branch is not a copy of your project. It's just a tiny, lightweight pointer to a single commit. That's it. It's basically a sticky note that you can move around. This is why creating and switching between branches in Git is so blazing fast. And that other special pointer, head, it's just another sticky note that tells Git which branch you're currently on.
Now, when you want to bring those changes back together, you've got two main choices, merge or rebase. Merging is all about preserving the literal truth. It takes your two separate histories and creates a brand new merge commit that ties them together. It shows exactly what happened, even if it's a little messy. Rebasing, on the other hand, is about telling a clean story. It takes your changes and, one by one, plays them again on top of the other branch, which gives you this beautiful, straight, linear history. It looks cleaner, for sure, but you're technically rewriting the past.
And speaking of rewriting the past, let's talk about one of the most powerful and often feared parts of Git, undoing things. This is where a lot of people get into trouble, but once you understand the philosophy behind it, it becomes a lot less scary. You see, older systems believed that history was sacred. It was set in stone. Every mistake, every typo, it was all recorded forever. Git has a very different philosophy, sometimes called history is a set of lies agreed upon. The goal isn't necessarily to have a perfect diary of every single misstep, but to present a clean, logical story of how the project evolved. And this philosophy is what unlocks some incredibly powerful commands.
So how do you undo things safely? Well, your number one safest bet is Git revert. It doesn't delete anything from history. Instead, it creates a brand new commit that is the exact opposite of an old one. It's a clean undo. Now, Git reset is where you need to be careful. A soft reset is like moving your bookmark back a few pages in a book. All the text is still there, you're just starting from an earlier point. But a hard reset, that's the danger zone. That's like moving your bookmark back and tearing out all the pages in between. Use it with extreme caution.
Okay, we've covered the history, the guts of the system, and how to stay safe. Let's wrap up by looking at how all these ideas come together to create really powerful workflows that let whole teams collaborate effectively.
One of the most classic examples is a workflow called Git flow. You can see the master branch up top. That is sacred ground. It's only what's currently live for users. All the new work happens down on the develop branch. When you start a new task, you create a feature branch from there. Once your feature is done, it gets merged back into develop. When it's time for a new release, you create a release branch for final testing. It's a really structured, predictable system that keeps complex projects clean and stable.
And that really brings us to the big, final question that Git kind of forces you to think about. What's the real goal of your project history? Should it be a perfect, messy, chronological diary of every single thing that ever happened? Or should it be a clean, curated, easy-to-understand story of how your project was built? Git gives you the power to choose, and how you answer that question will really shape how you and your team use this incredible tool every single day.